This month's lesson goes out to the New Hampshire math ninjas who live for your pie. Now this month's lesson is all about factorials. That's what this exclamation point right here is for. You see, in math, when we put an exclamation point after something, we're not trying to be exciting. This right here doesn't mean n. This means n factorial, which means we multiply all the integers from n down to 1. Let's find a few factorials. We'll start with 2 factorial. That means multiply the integers from 2 down to 1. That's pretty easy. That's just 2 times 1 gives us 2. Let's try 3 factorial. That's 3 times 2 times 1. That gives us 6. 4 factorials next. That's 4 times 3 times 2 times 1. But we don't have to multiply all that out. I see this 3 times 2 times 1. That's 3 factorial. So 4 factorial is just 4 times 3 factorial. And we know what 3 factorial is. It's right there at 6. 4 times 6 is 24. So 4 factorial is 24. Now we have a plan to find 5 factorial a little bit faster. That's 5 times 4 times 3 times 2 times 1. 4 times 3 times 2 times 1. That's 4 factorial. And 4 factorial is 24. 5 times 24 is 120. On to 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 factorial. 6 times 120, that's 720. Well, now you get the picture. Let's check out the problem. We're looking for 2 consecutive factorials here whose difference is 4,320. All of these are way less than 4,000, so I think we have to keep going. Let's try 7 factorial. That's 7 times 6 factorial. 7 times 720. And that gives us 5,040. Oh, that's more than 4,320. I think we found it. What happens if we take 7 factorial minus 6 factorial? 7 factorial minus 6 factorial. We get 4,320. We found it. But now we have to be careful, have to read the question very, very closely, because it's awfully tempting to write down 7 as our answer. But that'd be wrong. We're looking for 2 consecutive factorials here whose difference is 4,320, but we want n. We want the one we're subtracting here. N is 6, not 7. And we're ready for the next problem. We want the greatest integer p such that 33 factorial has 3 to the p as a factor. Oh, we definitely don't want to multiply out 33 factorial. That's 33 times 32 times 31, on and on and on and on. We just want to figure out how many factors of 3 there are when you multiply all those numbers out. So we only care about the numbers in that product that are multiples of 3. Let's go ahead and list those out. Our multiples of 3. Well, 33 is a multiple of 3, and then the next one we'll hit is 30, and then 27, and then on and on and on, and then eventually we'll get all the way down to 3. And there are 11 of these, because this goes from 3 times 11 all the way down to 3 times 1. So we have 11 multiples of 3. That gives us 11 factors of 3. Wait a second. What about 9? 9 has 2 factors of 3. Oh, every multiple of 9 is going to give us an extra factor of 3. So we have to figure out how many multiples of 9 we have. Now, the first one we'll hit when we go from 33 down to 1. The first one we'll hit is 27. And we'll hit 18, and of course we'll hit 9. So we have 3 multiples of 9. That gives us 3 extra factors of 3 when we multiply all these numbers together. But then I see that 27 sitting right there. Yeah, we've got a multiple of 27. Only one, just 27 itself. That gives us one more factor of 3. So we have 11 multiples of 3. That gives us 11 factors of 3. Then our 3 multiples of 9 give us 3 extra factors of 3. And then our 1 multiple of 27 gives us one more factor of 3. We don't have any multiples of 81, so we don't have to worry about any more extras. We've got 11 plus 3 plus 1. It's 15 factors of 3. So the answer to our question is 15. Ready for the last problem. We have a little arithmetic here. Now maybe you remember your factorials. You can just go ahead and figure this out. But if you don't remember them right away, we start from the smallest one, 3 factorial. That's 3 times 2 times 1, that's 6. We'll put that one in first. Then 4 factorial, that's 4 times 3 factorial. 4 times 6 is 24. Then 5 factorial is 5 times 4 factorial. 5 times 24 is 120. And then 6 factorial, 6 times 5 factorial. 6 times 120 is 720. Now it's just arithmetic. 120 plus 720 gives us 840. And we're dividing by 24 plus 6, that's 30. 840 divided by 30 gives us 28. But I got another way to solve this problem. Instead of multiplying out all these factorials, I'm going to start off dividing the top and the bottom by 3 factorial, because that's going to cancel out a bunch of stuff. If I divide that 5 factorial by 3 factorial, well, 5 factorial is 5 times 4 times 3 times 2 times 1. If I divide by 3 factorial, that'll get rid of the 3, 2, and the 1. Just leave us with the 5 and the 4. And then for our 6 factorial, if we divide that by 3 factorial, we'll get rid of the 3, 2, and the 1 at the end. But we'll still have a 6, a 5, and a 4. And then in our denominator, if we're dividing all this by 3 factorial, 4 factorial divided by 3 factorial, we're just going to be left with the 4. And then the 3 factorial divided by 3 factorial, we'll be left with 1. 4 plus 1, that's 5. Now we can cancel out a 5. We can divide the top here by 5 and divide the bottom by 5. Just leaves 1. We cancel out this 5, cancel out this 5. And up top, we have a 4 here. We have a 24 there. 4 plus 24, our answer is still 28. Live for your pie.